welcome everyone. Myself Imran Laiq from MSc Part 1, Rural number 37. I am going to present a presentation in organic chemistry under the title of Fundamental Overtone and Combination Bands Vibrational Coupling. My presentation including these contents. First of all, combination bands. Combination bands are observed when more than two or more fundamental vibrations are excited simultaneously. Combination band and overtones are used to help explain and assign peaks in vibration spectra that do not correspond with non-fundamental vibration. Combination bands and overtones generally have lower intensity than the fundamental because a split and shift in intensity affects with the similar energies and identical symmetries. For a nonlinear molecule, there will be 3n minus 6, where n is the number of atoms, number vibration. But for linear molecules, 3n minus 5 equation is used because a linear molecule has one least rotational degrees of freedom. The figure shows vibrating of diatomic molecule where the level denoted by vibrational quantum numbers, and we represent the potential energy for the harmonic oscillator. The transition from 0 to 1 is fundamental, but the transitions from 0 to n, where n is larger than 1, are called overtones, and transition from 1 to n, where n is larger than 1, are called hot transition or hot band. Symmetry requirements for vibration transition. The symmetry requirements of vibration transition is given by the transition moment integral. We can see here in the equation number 1, where the mu is equal to I mu x plus g mu y plus k mu z. Okay, and harmonic oscillator breakdown. The harmonic oscillator approximation is convenient to use for atomic molecules with quantized vibrational energy level given by the equation number 3. But more accurate description of the vibrational energies is given by the harmonic oscillator as shown in equation number 5. Equation number 4 in this slide. The difference in the wave function led to a breakdown of selection rules, especially delta V is equal to plus minus 1 selection rule cannot be applied, and higher order terms must be accounted in the energy calculations. We can see in this figure the harmonic oscillator approximation means green parabola superimposed on the anharmonic oscillator means blue curve on a potential energy diagram, where R is the potential energy of the diatomic molecule and R is the radius between the center of two atoms. Towards the left is compression of the bond, and towards the right is extension. Okay, next is overtones. Overtones occur when a vibrational mode is excited from V0 to V2, which is called the first overtone, and from 0 to V3 is called second overtone. The fundamental transition V is equal to plus minus 1 are the most commonly occurring, and the probability of the overtones repeat decreases as the number of quanta means delta V is equal to plus minus n increases. Based on the harmonic oscillator approximation, the energy of the overtones transition would be n times larger than the energy the fundamental transition frequency, but in harmonic oscillator calculation shows that the overtones are less than a multiple of the fundamental frequency. This is demonstrated with the vibration of the diatomic hydrochloric in the gas phase. We can see in this figure that the enharmonic frequency correspond much better with the observed frequencies, especially as the vibrational level increase. Special case: if one of the symmetries is doubly generated and the excited state, a recursion formula is required to determine the symmetry of the fifth wave function is given by the equation in this slide. Here is some explanation of combination bands. One reason a combination band might occur if fundamental vibration does not occur because of symmetry. This is comparable to vibronic coupling and electronic transition, in which a fundamental mode can be excited and allowed as a doubly excited state. To determine if two states can be excited simultaneously, the transition moment integral must be evacuated with the appropriate excited state wave function. For example, we can see here in the equation number 6. Here in equation number 7, in the point ground C4V, V1 has symmetry E and V3 has symmetry A2, but performing the calculation listed above, it's determined that 00 has A plus B symmetry. We can see here in equation number 7. The most organic liquids have strong overtone and combination bands in the mid-infrared region. Therefore, acetone, DMSO, or acetonitrile should be only used in very narrow spectral region. Solvents such as carbon tetrachloride, carbon disulfide, and CdCl3 can be used above 1200 cm upon -1. Okay, next one is vibrational coupling. Interaction between vibration can occur if the vibrating bonds are joined to a single central atom. Vibrational coupling is influenced by a number of factors. Number one, strong coupling of stretching vibrations occurs when there is a common atom between the two vibrating bonds. Number two, coupling of bending vibration according when there is a common bond between vibrating groups. Number three, coupling between a stretching vibration and a bending vibration occurs if the stretching bond is one side of an angle varied by bending vibration. Number four, coupling is greatest when the coupled groups have approximately equal energies. Number five, no coupling is seen between groups separated by two or more bonds. Here we can see the vibration coupling graph. The Q1 mode and Q1 mode vibration phase relaxation is shown, but in Q2 mode vibration energy relaxation is shown. Here are the references from which I have prepared this presentation. And finally, I'm thankful from all teaching staffs of chemistry department which helped me in completing my presentation work, and special thanks from Jitendra Paura sir for guiding me in organizing this project assignment. Wish you all the best in your academic career. Thanks so much from your attention.